So we're going to start with a small advertisement for the company. Basically, you know, Barclays has about 25 roles open. Most of them are in Java right now. So if you're looking for a job, I don't have an official speech prepared for that. So it's just, you know, we're a small development center, about 200 people. You know, we're growing rapidly. We're growing from 0 to 200 in 3 years. We want to double that in the next year or two. So there is obviously growth potential there. So if you're interested, let me know. I'll probably leave some of the business cards later on, and you know, we can take it from there. Even if the one thing I wanted to mention, like even if you're not interested in a job, in getting a job there, you should definitely participate in one of our assessment centers. So it's a whole day event where people are interviewed. Basically, it's not just a technical interview; it's a whole bunch of very cool event type stuff. The team building exercise and all of that. So it's a really good experience. So I'm going to be talking today about enterprise integration patterns. Specifically, I'm going to be talking about 2 implementations of the sort of enterprise integration patterns concept. It's a Sprint integration and then Camel. So I tend to speak very fast. If you have any questions, just raise your hand. Don't have to wait for me to stop, because that's probably not going to happen. So let's get started, I guess. So briefly about myself, I joined Barclays in 2010, worked there for about a year now. Really went from the algorithmic trading team, where I was in charge of the support tools and working tools, to the test automation team, where we build the test harnesses for tests in front of our systems and cache equities front to back. Before that, I worked for IDC and Monster. Both are really nice companies. Not as nice as Barclays, obviously. So today I'm going to be talking about, the presentation sort of will be in 3 parts. The first one will be about the business that I'm coming from, so you can sort of understand the problems that we're having there. The second part would be about enterprise integration patterns and sort of how they can solve our problems. And the third part would be basically about the Sprint integration and the practical experience that we had with Camel mostly. So now I have to explain investment banking in five minutes, right? So the investment banking is all about risk. Some people want to take more risk. They want to make money of it. Some other people want to get rid of risk in some way, hedge it, whatever. So investment banking is in the investment bank is in the middle. We bring people together, right? So we take care of that risk in one way or another. We do it in very different ways. It really there are whatever you think, whatever you can think of to manage your risk, there's probably an investment banking solution for that. So one of the most commonly known ones is equities markets, where you buy and sell stocks, right? And as being a part of a cash equities team, I come from that area. Algorithmic trading and electronic execution in general is very big in the equities market. So what we do is basically, in equities business, as a group, what we do is we buy and sell stocks on behalf of our clients, right? That's simple. Highly regulated business, a lot of requirements from the regulators, a lot of real-time reporting requirements, a lot of end-of-day reporting requirements, and it's a highly competitive environment. Now I'll talk about this a little bit on the next slide. So this is how it used to look like, let's say, 50 years ago. A bunch of people shouting at each other. Somebody on the phone wants to buy something, and then the guy, has to sort of communicate it to another guy, and they make a trade. This is how it looks right now. So really, the exchange is a high-performance data center, And that's it. It's all about technology. There is, I mean, there is very little left for the people to do. So electronic trading or electronic execution dominates equities markets. The reason is very simple. If it's electronic, it makes pretty much everyone happy. The investment banks are happy. You know, you can do the bigger volume. The bigger volume, the bigger the commissions and fees. It makes the regulators happy because you have tons of data, literally, to analyze through the day in real time or after the fact, and you can sort of prevent the fraudulent activities or, you know, punish people afterwards for them, if you want to. It makes customers happy because when banks compete on the technology, there's really, I mean, the technology becomes the key point in the competition. The margins are really tiny, and the volume grows. And for clients, it's really easy to switch from one bank to another. Literally, click of the mouse. Either you trade with one bank, and then you know the next minute you trade with another bank. So, really competitive market. And so banks are forced, and Barclays is not an exception there. The banks are forced to compete on the technology. So it's very important to deliver as good a technology as possible. That's why banks spend a lot of money on getting the top-notch, you know, piece of art, hardware and software, middleware, whatever. It's probably like, I don't want to be bragging about this, but basically, name any technology, any type of, you know, any type of problem, computational problem, or, you know, design problem. Somewhere in Barclays, someone works on that particular problem, or they have that technology or that piece of hardware. You know, cloud computing, it's there. So if you sort of start building out your trading platform from scratch, the very simple thing that you can do is you take you take this approach of you know, all I care about is getting orders in some way from the client, storing it somewhere, and then sending this to the market, waiting until it's executed by the market, meaning someone on the other side either bought or sell our stock or sell stock to us, and then report the execution back to client. So it seems very, very easy, but even there you can see sort of two separate concerns, right? So you have an order management system that's pretty much is responsible for getting the information that comes from the client, storing it, and routing it down to the execution stack. And execution stack sort of just routes it to the market. There is a connectivity piece somewhere in there, but in that simple scenario, it's usually connected really tightly with the execution stack. But then, once your volume grows and once your requirement grow, you start to think about how can you do these things better, how you can improve things, and really what you start seeing is multiple order management systems connect to multiple execution systems, connect to multiple connectivity applications that connect to multiple markets. In the US, we have like 80 markets we have to connect to, I think. In Europe, it's less than that, it's like 20, but still, each of them has their own protocol, their special, you know, special rules about the messages that they receive and give it back. So, and then you have obviously compliance, booking, allocations, you know, risk management, settlement. When the trade is made, you have to settle the trade after the fact. So all these pieces, all these systems, they sort of deal with this together. They're trying to solve this connected problem, but in reality, each one of them pretty much, in its nature, doesn't care about anyone else, right? So it's natural for this type of environment to have the messages that travel there are self-explanatory. So usually all you need to know is there in the message that you receive, either order or execution, trade capture, trade report. All the information required for processing that message is on that message itself. So you don't really care. An execution stack, for example, or algorithm that executes the trade doesn't care where the message came from, which particular OMS, and what was the processing logic in that order message system that get to this order. The connectivity doesn't care about which execution system sends an order, just cares about taking that message and delivering to the market as soon as possible. So the messaging, some type of messaging infrastructure seems to be a good solution for this. You sort of have this, already have this sense of the systems that are decoupled from each other and that they do processing on their own. And as I mentioned before, the orders and executions, all the messages, they sort of share the same, what you might call a canonical domain model, where when you get the message, you pretty much know what's going on there. And you don't need to imagine any or assume any type of context. You just take the message without a constant and execute that. And so when you think about that, there are many ways to integrate these systems. And the book, in this book, Enterprise Integration Patterns, very much is as a Gang of Four book that came out earlier about the design patterns. These guys describe the common problems they have, and they keep having over and over again with the integration of different systems. We are essentially talking about hundreds of applications running at the same time and communicating with each other. And so they outline, they basically talk about their experiences. And how many of you actually read this book? Anyone saw this book before? 1, 2, 3, 5? Come on. Okay, so 5 people. Okay, so the book is a really nice one. It's sort of like a reference, of the enterprise integration patterns. All right, so it's very, like, you need to read only like first 50 pages, and I encourage you to do so. And then the rest of the book is just sort of a catalog of the patterns, of the solutions. You have a problem, you have a solution for it. They describe generally 4 approaches to any type of integration problem. You have 2 systems, you want to connect them. There are 4 ways or 4 types of integration that you can do, right? One is a file transfer, where basically you have one piece of software that exports the data, and another piece of software that imports the data from the file system. And the file system is sort of the medium, right? Another approach, a bit more involved, is the common shared data storage or common data storage. It may be database, in-memory database, whatever. But the idea is that the storage takes care of the replication, and you sort of have this multiple systems connecting to the storage at the same time, and then you have to care about transactions and stuff like that, and multiple modifications. Simultaneous modifications. So RPC as another way of doing this, one application exposes a service, and another one is calling that service, usually synchronously, and waits for response, blocks until it gets one. And then there's messaging, which they claim to be a most complex type of the integration to master, but really the type that sort of gives you an ability to implement everything you had the previous 3 without losing any flexibility, sort of. It's going to be a bit more, it's going to be a bit harder, but you can do it. You can think of file transfer as transferring the message from one point to another, for example. So the basic concepts of the enterprise integration patterns, so there are 6 of them. Message and message channel. So these are 2 core concepts that they outline in the book. Really, the message is a sort of a small, and small here can mean, there's no limit how small it can be. It can be 15 megabytes actually, or more, whatever. It can be the whole document, or a snapshot of the database. I saw that done. So it's a piece of information, usually self-explanatory, right? You don't need to. You shouldn't be required to get some type of context to process that message. You should get it, and you should know exactly what to do with it. That's an ideal word, obviously. The channel is sort of like a logical point of integration between two pieces of software. The channels are usually implemented by the messaging middleware. If it's a JMS, then it's topics and queues, and if it's other type of middleware, obviously there will be some type of channel there, which is a logical addressing schema, let's say. Pipes and filters sort of builds on top of the message and the channel abstraction. Pipes and filters, basically, it's a concept that you have a channel, then you have this node that processes the message, and you should be able to chain them as long as you want to, right? So you put your processors, which were called filters for some reason, between the channels, and the channels, you use the channels to connect them, right? Message endpoint is another important pattern. We'll see that Camel actually uses the endpoint extensively. How many of you actually use Spring integration in Camel? Ever? 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 Not in production, like for your own stuff. Who read about this? No, who read about this at least a little bit? Okay, cool. Okay, so what I say, does it make sense? Like, am I going too fast, or? Okay, any questions so far then? No?
Can you elaborate more on pipes? I got that one about the filters, but I didn't get it.
Pipes is pipe is a channel. So basically, so the patterns, the way they describe patterns, they have a lot of redundancy, sort of, right? So when you talk about message endpoint, they have another pattern called channel adapter. And like, I spent like a half day trying to figure out what's the difference, right? And there is none. Well, there is some, like you have to really, really think about what they're doing, and then you sort of have this aha moment, and okay, so there is this tiny little difference, but you created the whole new pattern for it. So pipes and filters is when they say pipes, they are just talking about channels, but what they concentrate on is that idea that you can sort of connect them together, like sequentially, right? Rather than when they talk about channel, they concentrate on saying that they're basically saying that channel is a logical addressing scheme rather than any particular implementation of the delivery mechanism, right? So TCP/IP is not channel. Queue, whatever that, like queue is a channel. Queue can mean so many different things. So is a channel, right? So translators and routers are actually different types of filters, believe it or not, right? So it's filters that play a specific role in the enterprise integration pattern world, right? So translator usually translate the message. Surprise, surprise. Different implement. Again, the patterns description is very abstract, right? So they talk about these concepts and the particular implementations. Like if you start working with Spring integration, for example, they tend to follow these patterns to a T, right? Very precise about what they're doing. Camel, not so much. Apache Camel, they sort of took this one concept of endpoint, and they said, okay, this is we go with it. The rest is kind of, we'll open to interpretation, let's say. So router is sort of turns your pipe and pipes and filters infrastructure, which is basically sequential, and turns it into like a kind of gives you ability to connect multiple routes or multiple pipes, in that case, multiple channels. So here's an example of a typical, I obviously cannot present you with a real problem we have in our applications, but this is as close as I can get, right? So you have, this is actually might describe the whole application. You have an input channel where a bunch of messages are coming in. Let's say we pick it up from the wire. Usually, if you're working for an investment bank, your message-oriented middleware is very efficient, very fast. So they implement some type of hardware protocol usually, and they give you some sort of low-level API to go with it, right? So let's say we pick up the message from the wire, we send it to this original channel, it goes through the filter. The logic is very simple. First, there is a sort of type, order type on that message, which is basically either market or limit. Don't think like, just take it as a constant. Like, don't really try to. I guess how many of you know what market and limit orders are? Okay, so 2 guys from Barclays just raised their hands. Okay, that's good that you know. I mean. So these are just, think of it as a type of message, right? So we need to filter one type and throw away another type. And then there is another field, and we're basically saying, okay, if this field looks like this, in this example, ends with .L, which means, if you are interested, that this particular stock is traded on London Stock Exchange, as opposite to .N, which is NASDAQ. I think it's NASDAQ. So the .L symbols, the orders that, market orders that have that symbol that matches that regex, they will go to one channel. The others that are filtered successfully, they will go to another channel. This is sort of the diagram of the application that we want to have.
If you filter out the other messages, do you just drop them, or do you send them to another channel?
It's a good question. Here I don't really care about them. So, but I'll show you how I deal with it. I mean, we'll see in the implementation of this thing in Spring Integration and Camel, and you will see how I deal with that there. But here on the diagram, on the logical level, I don't really care because there is no processing for that. I don't know what to do with it, right? So so this we're kind of coming to the third part of the presentation where I start to show particular examples, right? So this is Camel. This XML is a Spring context, part of the Spring context. Camel can be configured by many DSLs. I'll talk about this briefly later. But so in order to compare it to Spring Integration, I kind of use the same sort of level, the playground, right? So this is the XML configuration. So Camel, when you configure stuff in Camel, it kind of makes sense. You have a route, a logical pathway, which represents what we have here in this picture, and you say from this URI, and we'll talk about URIs later, but this is basically creates an endpoint, and I pass it URI, and basically I allow Camel to resolve the endpoint that I want to use. I don't want to bind my application or, depend really on what type of endpoint I'm using right now. Then I have a filter. Then I have what would be called a router, I guess, in IP world, and it's based on the security, which is the field of the order. It routes the orders into VIP or regular channel, which is exactly what we have here, right? And then to answer your question, there's a trash channel at the end, right? Or trash endpoint rather, and that's where all the unused stuff go, right? So once they're filtered, they just they don't enter the filter declaration. They go directly to the trash. So to kind of summarize what we just saw, Camel really is all about roots and endpoints. The endpoint is your view onto external system, or not necessarily external system, but it's a sort of the biggest, the most widely used abstraction in Camel. Everything is the endpoint, pretty much. Roots are logical representation of your process in pipe, right? So if your process consists of several logical steps, they are going to be configured as one root. URI is used to resolve endpoints, and pretty much Camel really, the Apache Camel creators, they really like this idea of URIs. You kind of pass all the parameters through URIs. You configure your endpoint through the URI and stuff like that, and you get the endpoint. You don't really care about the particular implementation. And the important part, before I forget, everything is synchronous actually. So this process in here is done synchronously. So the thread that actually enters the endpoint at the beginning, the whole execution happens in the same thread up to all the way to the endpoint that the root ends with, right? We'll talk about asynchronous a little bit after this. So, okay, so this is Sprint integration, right? So really key difference here is that it's the same, so implementing the same problem basically, right? So the key difference here is Sprint integration cares about channels. If you take a look at I actually can show you this. If you take a look at Camel representation, you don't see any channels there, right? It's just endpoints. So Camel takes care of connecting the endpoints and other components together. Here, you care about channels. You specifically configure them, and you connect components to those channels. So with the Sprint integration, what you're really doing is you're building this a network of channels, or like a messaging bus, and you connect your stuff to it. Like, and there is no concept of root or anything like that. You can sort of get a similar behavior that you get from Camel using the chain component of the Sprint integration. It sort of takes care of the pipes or channels, but for you, very much in the same way as Camel does, but it's not as advanced. And I mean, it's just one of the options. So again, the Sprint integration takes patterns, enterprise integration patterns very seriously. They take care about pipes, filters, channels, everything like that. Camel just takes endpoint and sort of rolls with that, right? Everything is endpoint. We concentrate for every system that we want to integrate to. We want to create an endpoint. The key thing there is that Sprint integration allows you to configure your components separately. So if you want to do some sort of like type of aspect-oriented programming where you want to put an interceptor on some channel, you can do it in some other some other Sprint context configuration that you can include, and it's very easy to kind of get lost in all this configuration. In Camel, the root is sort of logical path. So if you want to put an interceptor, it has to be in that place. You cannot really screw it up by putting it somewhere else and forget about this, right? So, but there are obviously drawbacks of that from that approach. Like if you want the wiretap, which is sort of like a listener that drops everything to reporting channel, you have to configure it in root, while it doesn't have a direct relationship to your processing logic, right? So you sort of lose the. So this is just one part. What we talked about is messaging inside one application, usually inside one VM, right? So with Camel, this Spring Integration and Camel, they sort of come from two different ends. Spring Integration was specifically designed for lightweight messaging inside one application. So you build your application embracing these enterprise integration patterns on a very low level. So you say, my application is actually listens here, sends here, processes here, and you want to do the plumbing with this type of framework. Camel comes from another end of the spectrum. It sort of concentrates on integration of the systems. So as a result, they have a little bit different. They have a bit different approaches to. Let's say they consider different things to be important. Like I said, Camel considers endpoint to be very important because the endpoint is a view on every system that you want to integrate with. But second part of the problem is really this part where I want to take this file from that FTP server. I want to process it. I want to send an email. If I don't get a reply in a certain time frame, I want to send an SMS message, and I want to send a tweet, right? Or more complex logic like that. Or you just want to copy file from one FTP to another. So, or you want to copy it from FTP into SFTP server, whatever. So in these type of scenarios, they both support that. They sort of, Camel takes, Camel does a better job of coming up with the out-of-box solutions. Camel supports more than 60 different endpoints. You name the protocol or the system, they probably have it. And there are a bunch of extensions that they can use. They didn't include in the core, but you can use them. They are open source, and you can get them from the internet. Spring Integration actually comes with like about 20, something around 20 endpoints, or they call it, I think, channel adapters or gateways into other systems. It's basically the most common ones like GMS and email and SMS and I think a bunch of others. But they're catching up. So in version 1.1, I think Spring Integration had like, I don't know, like 6 of them or something. So really, the summary of these two things, both frameworks deliver on both promises. Both frameworks are, I think, mature enough to be used in production. Camel is, I think, 5 or 6 years old. Spring Integration is a little bit less than that. They both have great communities. Both have really nice, they have a roadmaps. They have mailing links, everything there. So very responsive. I committed code to both of them, contributed code to both of them. The community is very responsive. So if you want to decide which one to use, you can flip a coin. The one thing I would urge you to do is, heads, take Camel, tails, take Spring Integration, but only if coin hangs in the air, then write your own solution, right? Stop writing filters, stop writing abstract processors and stuff like that. Whenever you whenever you create a class and you call it abstract processor, just stop there and just go for it. So briefly, as briefly as I can, the topics that we didn't cover and sort of what we're working on right now, and sort of where I want to take this framework in the company, right? The couple of points that we didn't talk about is actually messaging persistent, right? So when you have a queue or the channel in Spring Integration, you have an option of persist. By default, it's just in memory queue, but you have an option of persisting that. They even support MongoDB and stuff like that right now with a 2.1 version. Camel doesn't have that. So if you want a persistent for your messages, you would go with an endpoint that allows that. Or you would have to implement it yourself in some way. There are some the basic storages, but they all are in memory, I think. The parallel asynchronous processing. So all of the tasks that I showed and the both implementations are actually, if you code it up this way, they're going to be synchronous, right? So the same thread, the same transaction, the same execution context, but it's very simple to go asynchronous. So when you in Sprint integration, it's enough to change your channel, which is by default is I think a direct channel, or called something similar to that. It's very easy to go from that to the queue, right? So your channel is actually a queue, and your thread that puts stuff into the queue doesn't block until the consumer, doesn't wait the consumer to pick up the stuff, right? So what you would do is actually, on the configuration level, change the behavior of your application. Of course, you have to be careful about the threading and transaction and security context propagation, right? So low latency messaging applications, this is something we will try to do probably at some point in Barclays, because really, and in that case, to be honest, I think we're likely to go with Sprint integration because of the lightweight nature compared. I mean, even in low latency, even creating one extra object matters, and Camel kind of has that additional layer of abstraction. Complex event processing. Who knows what complex event processing is? Anyone ever heard? Okay, I'm going to skip that. DSLs, Camel has a lot of DSLs apart from the Spring one that I showed, right? You can configure it from Java, Scala, what have you. And the idea is that you can dynamically configure your routes and connect them to your context with a VM endpoints, for example. Then there is also tooling. So there's this company called Fuse Source, I think. They provide this Fuse ID, which has a sort of VZVIC editor for Camel context. And what's really cool is that if you pay for it, obviously, it allows you to debug your routes in runtime. So you literally can drop a message on one end and trace it through all the endpoints and see it. I think they employ the GMX interface there, but you can see literally what's going on with your message through the route and see it almost like it happening graphically. So unfortunately, the debugging part, I think you have to pay for it. So that's pretty much it. To be honest, so to kind of wrap it up, in Barclays, when I started working there a year ago, it'll be more than that, we started with Sprint integration. Back then, it was 1.2, I think, version, or 1.1, some of the 1 dot something. And then we switched to Camel, simply because what we care most of all about is the integration with other systems, right? So for us, having multiple connectors and write as little code as possible for connecting to the system is the key. So that's why we went with Camel. Like I said, if we were go to low latency applications, something like Exchange Emulator, for example, where you really care about how fast you can process stuff and how you want to really concentrate on the thread scheduling and sort of like, anyone knows about disruptor pattern or disruptor framework? Yeah, so I think you can achieve some of that awesomeness in using Camel Sprint integration partially and using the channels that are based on tasks executors to sort of get the same type of application. So anyway, that's it. Thanks.